I'm Josiah, and this is Alec. So, our friend Steve is about to eat a sandwich that he just made. Steve can only open his mouth so wide, a height of H max, and our sandwich is H thick. So, we have to figure out how much force Steve has to push down on the top of the sandwich for it to shrink a little bit so that he can fit it in his mouth for this bite. What we know are the flexibilities of the lettuce, tomato, and bread, since Steve is a vegetarian. And we also know the initial height of the sandwich, given right here, little h, and then the maximum height, or how wide Steve can open his mouth. So basically we're solving for P-min here. We're going to start this problem off like we do solve problems with a free body diagram. Just down here. So we've got 2P going down, and then our R reaction force going up. It's got to equal 0. So this tells us that the reaction force is equal to 2P. Clearly that's not enough to solve for our force P, so we're going to have to examine the flexibilities of the ingredients. So, number 2. Basically, we're going to look at each individual part, and the total elongation is going to be the individual elongations summed together. And we know that the elongation delta is equal to the force times the flexibility of the material that it's acting on. So we're going to add up all the deltas for the lettuce, tomato, and bread. So starting with the bread, the delta is equal to the force R times the flexibility of bread, FB. And also, since there's 2 slices of bread, we're going to multiply this by 2. And then for the delta T, kind of the same thing, R times FT, and then the same thing for the lettuce, R times FL. So we have these 3 force displacement relations, D, and then we're going to move on to our compatibility equations, which will be number 3.
All right. Goal here with compatibility equations is to relate the changes in height to each to the overall force so we can go back and find P-min. So we know that our initial height is H, and we know that we're trying to get to H max, and we know our compressions of each section of the sandwich. So all of the compressions added up, call it delta total, has to be the difference between H and H max. So H minus delta total equals H max. So we write in specific values. We get, for the bread, 2R times FB, which is 0.07, plus tomato, which is R times 0.42, and then finally the lettuce, which is R times 0.5, and that is equal to 4 inches.
Also, we're subtracting the delta total from the initial height H because we assume that all of the deltas are positive. We have to subtract because we know that the delta has to be negative, it has to be subtracted from the initial height for the final height to be less than the initial height, of course, if Steve's going to compress this in. So we should explain that.
Now we can pull out an R and compute specific values. And if if you do this correctly, you should get that your R is 1.085, which means that P is half of this, which equals 5425 pounds. So Steve must apply 0.5425 pounds with each of his hands in order to successfully take a delicious bite of his sandwich.